What is asphalt? Hey, engineering lovers, have you ever stopped to think about what makes up that smooth and resistant surface we travel on every day? Asphalt is so present in our lives that it often goes unnoticed. But without it, our mobility and infrastructure would be completely different. Behind this seemingly simple layer, there's an ancient history, complex chemical processes, and precision engineering. But after all, what is asphalt? Let's unravel together this mixture that shapes the modern world. In technical terms, asphalt is a binding material of organic origin, composed mainly of bitumen, which is a black, viscous, and highly adhesive substance, along with mineral aggregates like sand, crushed stone, or gravel. Bitumen, which acts as the glue in the mixture, is a petroleum byproduct or can be found in its natural state in some places on the planet. Chemically, bitumen is a complex mixture of high molecular weight hydrocarbons containing mainly carbon and hydrogen, as well as sulfur, oxygen, and nitrogen. It doesn't have a unique chemical formula since its composition varies according to the source of the petroleum, but its structure is defined by molecules like asphaltenes, which are responsible for rigidity, and maltenes, which provide flexibility. It's important to say that asphalt is a composite material, meaning it's not just bitumen, because what makes up asphalt also includes the addition of aggregates. As I already mentioned, it's important to say that asphalt is a general term that refers to the material used for paving, but there are different types of asphalt. For example, there's hot mix bituminous concrete, which stands for hot mix bituminous concrete, and it's used on our streets and highways. But we also have cold mix bituminous concrete, which is cold mix bituminous concrete, commonly used for small repairs on low traffic roads, polymer-modified asphalt that increases strength and durability, and even rubberized asphalt, which uses recycled tires in the mix. But when asphalt or bitumen was discovered, the history of asphalt dates back to ancient civilizations. Archaeological evidence shows that the Sumerians, more than 5,000 years ago, already used natural bitumen to waterproof water reservoirs and temples in Mesopotamia. The Egyptians used it to embalm their pharaohs in their mummification process. And the word asphalt derives from the Greek asphaltos, used by Herodotus to describe the natural deposits found in the Dead Sea. However, the material was first used for paving in the 19th century. In 1870, the Belgian-American chemist Edmond de Smetit paved the first street with modern asphalt in Newark, New Jersey, using bitumen from the island of Trinidad. But as for how asphalt is produced today, the whole process starts with the refining of crude oil. During fractional distillation, the oil is heated in industrial towers, separating into fractions such as gasoline, diesel oil, and kerosene. The heavy residue from this distillation, called vacuum residue, is subjected to processes such as vacuum distillation or propane deasphalting. To extract pure bitumen, this bitumen is then heated to about 150 to 180 degrees and mixed with mineral aggregates that have been previously dried and heated. In asphalt plants, the typical ratio is 5 parts bitumen to 95 parts aggregates. In other words, the bitumen acts like a cement or glue, and the aggregates make up the largest volume of the asphalt. After this homogenization, the mixture is transported, still hot, between 140 and 160 degrees Celsius to the application sites, where it is compacted by mechanical rollers to form a uniform surface. And the most interesting thing is that all of this starts in the same place. In petroleum, yes, the asphalt that covers the roads of the world is one of the most valuable products in the oil industry, and understanding this is just the beginning. Getting back to the subject, what are the applications of this versatile material? The most well-known is road paving, where about 90% of paved roads in the world use asphalt. Because of its durability, load resistance, and ability to be quickly repaired, but its uses go beyond that. In civil construction, asphalt membranes or sheets are essential for waterproofing roofs, foundations, and tunnels. Here, it's important to understand that the asphalt sheet is not asphalt itself, but it contains the same bituminous base material used in asphalt. In airports, high-performance asphalt supports the weight of aircraft without deforming. In industry, the bituminous material used in asphalt is used in explosive coatings for pipelines and storage tanks. And again, here I say that it's not asphalt itself, but rather the binder. Even in dams and landfills, it acts as a sealing layer against leaks. But why does asphalt remain irreplaceable? Well, its unique properties explain its predominance. It offers superior grip, noise reduction compared to concrete, and flexibility that absorbs impacts and temperature variations without cracking. In addition, it is the most recycled construction material on the planet, according to the National Asphalt Pavement Association of the United States, where more than 99% of the asphalt removed during renovations is reused in new mixtures. Innovations like warm mix asphalt or warm mix asphalt, which can be produced at temperatures between 20 to 40 degrees, lower than conventional ones, they reduce carbon monoxide. Two emissions and additives like used tire rubber or polymers increase its lifespan. However, challenges remain. The dependence on petroleum makes asphalt sensitive to price fluctuations, and research is seeking sustainable alternatives, such as bitumen derived from biomass or microalgae. In fact, one of my first theses was focused on polymer-modified asphalt and how it can increase compressive strength. And that earned me one of my first interviews because of the research. Road maintenance in extreme climates also requires specific formulations, such as the use of elastomer-modified bitumen for glacial regions. You see, asphalt is much more than just a simple street covering. It's actually the result of millennia of technical evolution. A complex colloidal system that balances geology and engineering, from the waterproofing of reservoirs to high-speed highways. It shows how this seemingly rudimentary material can be the foundation of human connectivity. And as we search for more sustainable solutions for the future, one thing is certain: asphalt will remain beneath our feet, wheels, and dreams of progress. If you've made it this far and enjoyed the video, make sure to subscribe if you haven't already, leave your like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you're interested in discovering the courses we recommend, scan the QR code here on the side or check the link in the video description to see our list of courses. And it can take your resume to another level. So, did you know what asphalt was? Do you prefer asphalt or concrete roads? Let us know in the comments. On the side, there are 2 videos you should watch to expand your knowledge and curiosity. And if you want to support us, leave your like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering fans. Big hugs. See you in the next video.